Integration by partial fraction decomposition. In short, we say PFD. Okay, let's consider a rational function of polynomial divided by another polynomial. When we have a rational function like this can be a proper or improper. Let's consider first proper. Proper means the degree of the top is less than the degree of the bottom. In that case, we can always write this rational function as a sum of simpler fractions. Okay, can be two simpler fractions or more than two. Okay, if the degree of the top is equal or more than the degree of the bottom, if the degree of the top is bigger than or equal to degree of the bottom, then we first need to divide the top by bottom by long division to write in this form. So we'll have some quotient plus remainder over this q. In this case, this becomes a proper. That means the degree of the top is less than the degree of the bottom. Something like this. If we are asked to evaluate this fraction, this is a degree 2 polynomial, degree 1 polynomial. So this is improper because the degree on the top is equal or bigger, in this case bigger than degree of the bottom. So to integrate this fraction, first we need to divide the top by bottom using long division. So what we do is just write the top, that is x squared plus 3x plus 3, and we divide by bottom, which is x plus 1, and the quotient goes here, this part. Now we just look at the first to first. So x times what gives us x squared? Just x. Now x times x is x squared. Now we multiply both terms by x. So we get x times x, x squared plus x times 1, 1x. And now we subtract. Subtract means we change the sign of bottom. Okay, so cancel. 3x minus x, just 2x, and leftover is plus 3. X, 2x, we need to divide. X goes how many times to 2x? Just 2, is a plus 2. So plus 2 times x, 2x, plus 2 times 1, plus 2. Again we subtract, minus minus, cancel. That leaves 3 minus 2, 1. So this fraction is in fact integral of x plus 2 on the top. X plus 2 is a quotient plus remainder 1 on the top over x plus 1. So we can write this fraction as this. In terms of numbers, you might have done, if this is new for you, it's like doing like 7 over 2. When we divide 7 by 2, 2 goes how many times? 3 times. Then left over 1 half. 3 plus 1 half. It's like that. Or we also write this as 3 and 1 half. Okay, it's same idea here, but we are working with polynomials. Okay, so we simplified this fraction as this, and we have dx, by the way. Okay, let me change the color. Now we take the antiderivative. Antiderivative of x, which is x squared over 2, plus antiderivative of 2, which is 2x, plus, now we got a fraction, but this is simple. So we know that 1 over x plus 1, this is in fact, since the top is derivative of bottom, this is simply ln of x plus 1. Okay, ln of absolute x plus 1 plus c. Okay, so if the given fraction is improper, first we need to do long division like this, then write in this way and integrate. Now let's consider the case where we have a proper fraction. Proper means the degree of the top is less than the degree of bottom. And case 1, so we have several cases. Suppose q, the bottom polynomial, is a product of distinct linear factors. Suppose this factors is several linear factors. Linear means degree 1 factors. That is, say q is just L1, L2, Ln. Then we can write this complex fraction as some number over first linear factor plus some number. A1, A2 are numbers, okay? A1 all the way to An are just constants, means numbers, over L1, L2, Ln are just linear factors. This could be like x minus 1 or x plus 2, x minus 7, etc. So we can always write in this way. Then we can easily integrate after that because these are simpler fractions. So here is an example. We just want to set up the integral in terms of partial fraction decomposition. So we don't have to do it, but we can do it anyways. Here this is proper in the sense this is degree 1. If we multiply the bottom two factors, we get 1 1x squared. Degree 2, this is degree 1. So this is proper. We don't have to do long division. Now the bottom is a product of two factors, like let's say here like L1 and L2, two factors. Then here it's possible to write, let this fraction as some constant over first factor, or second doesn't matter, plus some constant to be determined over x minus 5. So we can write this complex fraction as a sum of simpler fractions called partial fractions. Then we can easily integrate these two fractions because these are numbers, okay, just numbers. So we can integrate first, then we can go back and plug in the values. Anyways, let me solve this completely. So we let this. Now we want to determine the values of a and b. To determine the values, we always multiply throughout by the common denominator, which is this, x plus 1, x minus 5. Then left side, these two cancel. Then only the top survives. I mean, that's how we design every single time. We just multiply by this, both sides. So x plus 1, x minus 5 cancel from this fraction, equals, now this is a times x plus 1 cancel, what is left? X minus 5 plus b, x minus 5 cancel, x plus 1. Okay, so we get this. In fact, if you look at closely, if we have distinct factors, so this is a times x minus 5 plus b times x plus 1. Now to determine the values of a and b, we assume this is true for any values of x. Now we choose certain values of x so that our calculations are easier. So choose x equals, so let's choose x equals 5, then 5 minus 5, 0. So this is gone and we can determine the value of b. Next we choose x equals negative 1, negative 1 plus 1, 0. Then we can determine a. So this is how we choose a x value. So let's choose 5. Then 3 times 5, 15 plus 1, 16 equals 5 minus 5, 0. So this is nothing. 5 plus 1, 6, b. So we have 6b equals 16. So b equals 16 over 6. and goes 8 times, 3 times 8/3. Next we choose x equals -1. 3 times -1, -3 plus 1, -3 plus 1, -2. -1 minus 5, -6a, plus -1 plus 1, 0. This is 0. This is, now we divide both sides by -6, so a is -2 divided by -6, so this is times, okay? Negatives cancel, 1/3. So this fraction is in fact a over x plus 1. So 1/3 over x plus 1 plus 8/3 over x minus 5. So we can write this integral 3x plus 1 over x plus 1 x minus 5 is a over x plus 1. A is 1/3 over x plus 1. Okay, we have integral sign, plus b is 8/3 over x minus 5 dx. So it was complex fraction. Now we simplified as a sum of simpler fractions. Now this is same as integral of first plus integral of second, and we can easily integrate. How? Integral of first means this is just, we can pull 1/3 out, 1 over x plus 1 and dx, plus 8/3 we can pull outside, 1 over x minus 5. Now 1/3, the top is derivative of bottom, so natural log of bottom. 8/3, the top is derivative of bottom, so ln of x minus 5 plus c. Final.